Hi everybody, thanks again for joining us today and welcome to today's webinar. I'm Lindsay Teal and I'll be your host today, and the session should last around 40 to 45 minutes. We're joined today by my colleague Rob Snaith, and Rob is one of the specialist energy implementation advisors here at Resource Efficient Scotland, and he's worked with organisations across Scotland to help them implement successful energy efficiency initiatives, so he's going to share some of that experience with us today.
Thank you, Lindsay.
Just before that, sorry, if you've got any questions throughout today's session, then you'll see on screen now that the questions box is there. So at any point, just type your question in there and we'll stop at 2 points throughout today for Rob to answer those questions. And if we don't get to answer them all, then don't worry, we'll follow up with you at the end of today's session. And also, if you enjoy tweeting, then do so to @ResourceScot, and you can use the hashtag ResWebinar. And if you want to use that for posting your questions as well, then do so. And so, yep, with that, I'll hand you over to Rob.
Thanks very much, Lindsay, and thanks for everybody, for dialing in. What we're going to look at today is, as you see here, why looking at space heating is important. It's one of the biggest costs that most businesses have. A few little points about understanding what your current energy use is for space heating and how to analyse that. Then we'll have a look at the top 10 issues and ways to address those issues which have come up in a lot of the work that we've done. And then we'll have a quick chat about how Resource Efficient Scotland can help you to take the next steps after today and look at reducing your own heating use. Sorry, I'm going the wrong way there. Okay, this is a very kind of simple slide here. Why should we be looking at our energy use? The green line is for the retail price index, which is the general measure of inflation. And as you'll see from the orange line, energy prices have vastly outstripped that. The line here is for domestic energy, as you see, but small to medium enterprises energy prices are very similar. So, as I said before, energy and heating especially is usually the largest and most visible cost for most organisations. So it makes sense for us to try and tackle that as much as possible. Why is it important to understand your current energy use? There's no way that you're going to be able to start making savings if you don't understand where you're spending money in the first place. The first thing that we say to every organisation that we speak to is to get a good idea of what your energy use is, to analyse that data, and then you can start setting targets and looking at ways that you can reduce that cost. We're going to kick off with a quick poll here, so I'll hand you over to Lindsay.
Yeah, so sorry. So coming on screen now is the first of the polls that we want to run, and it's how effectively does your organisation monitor space heating consumption at the moment? So the options there on screen are A, very well, B, well, C, okay, D, not well, and E, very poorly. So if you could just take a couple of moments to complete that, then it'll just give us an indication of where you're at currently. So most people are taking the time to do that now, and maybe not so surprisingly, a lot of people are sitting at the not very well and very poorly end of that spectrum.
Absolutely, which completely reflects the experience that we have with working with organisations through Resource Efficient Scotland. It's not a difficult thing to begin to get to grips with, but it's taking those first few steps and understanding what you actually need to do to have a good idea of your energy use are the most important things, which we'll chat about in the following slides after the poll's completed.
So I think most people have completed that, so I'll close that poll there and I'll just share the results with you. So it's 0% feel like they're doing it very well, so hopefully maybe you'll be able to click that button at the end of the session. The 12% well, 28% okay, 44% not well, and 16% very poorly, so definitely room for improvement there.
Absolutely.
So you're in the right place. So I'll just pass the slides back over to Rob.
Okay. Heat use generally, I mean, you see here the three types of heat use that there are. You've got convection, conduction and radiation, and you can get heating systems which use all of these types basically. Getting an idea of why what the people's different levels of thermal comfort are is also a very important thing to do as a simple kind of staff survey. you can see the different factors which have an effect on what make people feel comfortable within any kind of organisation, within any building. Also the different sources of heating you've got in your organisation. People themselves generally release, we say normally about 100 to 120 watts into the atmosphere. You've got the thermal mass, the building itself, the heat that's stored in the structure of the building. Insulation, which is the heat from the sun. So if you've got large windows in your building, then you're going to have a lot more heat coming in than if you've got smaller windows. IT equipment, cooling equipment, refrigerators, cooling fans on fridges and things, they extract the heat from inside the fridge to keep your food cold, and that heat has to go somewhere. Generally it's just kind of kicked out the back into the building itself. Process equipment if you have heavy plant or machinery, and finally your actual heating system, which is kind of on top of all of that as well. There's lots of different sources of heat coming into a building, so you need to be aware of where everything's coming from before you can start to get a grip on kind of how you're managing that. Understanding the way that energy and heat in particular is measured is also an important thing to enable you to have a good understanding of what the possibilities of reduction are. Energy is measured in kilowatt hours, kWh, and 1 kilowatt hour is the same as 1 unit of electricity on your bill. For gas bills, your gas bill will generally be measured in meters cubed of gas, and there's a conversion formula on every gas bill to show you how that's been converted into kilowatt hours, the standard unit of energy. If we look at the gas example there, if you have a 27 kilowatt domestic gas boiler, that would be a large domestic boiler or a small commercial boiler, running at a load rate of about 30%, then the power rating of that boiler running is 8.1 kilowatts. If that runs for an hour, you've used 8.1 kilowatt hours. And then from your bill you'll be able to see what your charge per kilowatt hour is, and you can have a good idea of how much your heating system is costing you. So the initial inspection of just purely your bills is the first step to take, and kind of making a note of that data and monitoring it over a period of time is the best way to begin to identify trends and see where there might be issues in your energy use. What kind of data should you collect? Like I said, recording your usage from your bills is the simplest way to do it. There are more sophisticated metering technologies which you can install, automated meter readings, half-hourly meter readings for larger energy users also. And if you can collect at least a year's worth of data, preferably kind of longer than that, over 3 years generally is a good starting point to be able to identify trends in your energy use. If you look at if you've got hot water use in your organisation as well, generally about 10% of your heating energy will be going towards hot water use. So as you can see from the graph there, once you've started to gather that data, you can start to build up a picture of, hopefully you should be seeing a lot more heating in the winter times, but if you can see any kind of aberrations or trends which aren't as you would expect to see from that graph there, that's where you can start to target any improvements that you might be able to make. Electric heating is a very expensive form of heating. It's not as prevalent as it has been for the last kind of 20-30 years or so. It's beginning to be phased out a bit now, but I'm sure it won't be an uncommon idea to a lot of people. The electric storage heaters, direct electric panel heaters. One of the difficulties with electric heating is obviously every organisation will have general electricity use as well. So if you just have one bill for your electricity, it sometimes can be hard to identify which of that use is going towards heating and which is your general lighting and appliances and things like that. So as a general rule of thumb, it is fair to assume about 50-50 for most small to medium organisations. So it's just another factor to be aware of when you're thinking about what you might be able to do. So now we'll go on to the top 10 tips, the things which have kind of come up most commonly in the organisations that I've helped and we as a programme at Resource Efficient Scotland have been working with. The first one, we've touched on it already, monitoring. It's the most important thing that any organisation can do, is just to to get a good idea of where your energy use is, and any trends and any kind of aberrations which you can begin to look at. A few very little simple things that you can do. Just record the settings that you've got on your system, a simple kind of record sheet. Change the settings, change the temperatures on the thermostats, record the date that you've made those changes, and you can see how it has reduced or increased your energy use over a period of time. Something as simple as putting dates in the diary to clock changes. So you know, for Christmas holidays or any other days where you know the business isn't going to be working, you don't want to be heating your space in a time when it doesn't need to be. Another nice little test that you can do is looking at weekend use. If you're not operational over the weekend, just record the weekend use for a few weeks in a row, and then do a test weekend. Let everybody know that you're going to be recording the weekend use that time, and ask everybody to make sure that absolutely everything that can be turned off over the weekend is turned off. And then from that you'll be able to see what the difference is between the standard status quo, and potentially kind of target some changes to be made to reduce your general energy use. The second point is benchmarks. Benchmarks are a way of measuring yourself against other organisations within your sector, so you can see what the expected energy use for your type of organisation would be, and see where you come up against that. Helps you, as I say, understand your current costs in the context of your wider sector. Helps you set targets if you want to bring yourself down to the benchmark or below the benchmark. It's a nice focused way to target yourself. You can get a good idea of how much it is possible to save. We go into a lot of organisations and they say we've been given a target of saving 15% of our heating costs over the next 1, 2, 3 years. And then if you look at the benchmark and they're already at or about the standard for their sector, then savings of that level just aren't going to be possible. So it helps to keep things in perspective as to what you might actually be able to do. And they're a useful way to begin conversations with decision makers, people who might be kind of making the decisions on whether or not to invest in a certain piece of energy saving kit. If you can say, this is where we are, this is where we ought to be, then you can begin to make the case for that investment. For larger organisations, degree day benchmarks are something else to look at. Degree days are generally a way to measure your heating use against the external temperature over a number of years. So you can see how your building has been performing, how your organisation has been performing against not only the general sector expectations, but the climate expectations as well. So you can also connect, it's the next level of identifying any kind of trends which might be out with what's expected. Just a few examples there of standard benchmarks. CIBSE is the Chartered Institute for Building Service Engineers, and they produce the general benchmarking figures for most of the organisations in the UK. So you'll be able to have a look at that list and see if you kind of compare. If you've got a good idea of your energy use already, you might be having some alarm bells ringing, or it might be an exercise for you to go away and kind of have a look at that. These figures here are measured, as you'll see, in kilowatt hours per metre squared per year. So that's units of energy per metre squared in your building per year. So that's, again, with a little bit of analysis of your bills at the very top level, you should be able to get yourself a rough figure and see where you compare with those. Next tip, improving the thermal performance of your building, insulation, basically. There's a few different areas of a building that can be insulated. The main two are the roof and the walls. Generally, we'll say any building will lose about 20% of its heat through a completely uninsulated roof. The different ways of doing that obviously differ for individual buildings. You'll see a few of the kind of the standard ways in the pictures there. Just laying down simple mineral wool material in a loft. The picture on the bottom left there is a sprayed insulation material. It looks a bit like the old expanding foam you used to get. It's the stuff they use now is not the same as that. You'll be happy to hear, because that did lead to quite a few issues with dampness problems and things like that. There's lots of materials available now which are breathable, so they allow moisture to pass in and out of the building as it's meant to, yet still retain a lot of the heat within the building. This really improves the thermal performance of the building. Wall insulation is the next big one. Generally, we'll say about 15% of a building's heat will be lost through the walls. Cavity wall insulation is probably the most popular one, or the most kind of common measure installed in the UK at the moment. If your building's of brick or block construction with a cavity in between two layers of brick or block, and most buildings built from about the late 1920s up till the late 80s, early 90s will be of that construction in the UK. Then you can fill that gap in between, again with a breathable material, which still allows any moisture to flow in and out of the building as it's required, but really improves the thermal performance of your walls and makes a big difference in how warm the building is. The one issue that you do need to be aware of with cavity wall insulation, if you are in a very exposed location, so the far west coast, out on the island somewhere like that, or up on the north coast, then driving wind and rain can still cause a bit of an issue with cavity wall insulation, purely because of the moisture ingress and egress from the building, which is required in those conditions. So any cavity wall insulation installer should be able to make sure that your building is firstly suitable, it's of the right construction, and it's in an appropriate location to get that work done as well. Older buildings with solid brick or solid stone walls, insulation is a bit trickier. It's not a low-cost measure anymore when you get to that type of construction. It can be an expensive thing to do. Can still be a very worthwhile thing to do. It's really down to a case-by-case investigation as to the kind of the cost benefits and how long that type of work is likely to pay, but it's definitely something which can be done and which we've done quite a lot of work with as well. On to the next tip, looking at replacing your heating system. Basically, if you've got a boiler which is anywhere between 15 and 20 years old, it's probably going to be beginning to decline quite rapidly in its efficiency. So looking at replacing that, the different options of replacing your heating system is probably one of the biggest savings any organisation is likely to be able to make. When do you upgrade your boiler? You can check your boiler efficiencies for the vast majority of small commercial and kind of large domestic, which kind of feeds into a lot of SME size organisations. You can check the efficiency of them on a government website, which we'll have a link to in one of the following slides, I believe. Generally, the age of the boiler is a good indicator. If your boiler's been well looked after, if you've had a maintenance check done every year, then we would normally expect a standard gas or oil boiler to last about 15 years before it starts to drop off quite rapidly in its efficiency. If you're getting to that stage and you're finding you're having more and more issues with maintaining the boiler and having to get people to come out and look at it, then that's obviously a bit of a clue that things maybe aren't running so well, and it's about time to start thinking about upgrading. There we go, that's the website I mentioned earlier, the Performance Characteristics Database, PCDB. So you can just pop in the make and the model of your boiler and it'll give you a rough idea of how efficient it will be working at the moment. As we say, there are many SMEs, the vast majority that we speak to are using domestic size boilers. So that's where the information that you can find on that kind of range of technology is. Any new boilers now in the UK, any new boilers that are installed have to be A-rated, which means they're more than 90% efficient. And that legislation came in the late 90s, as you see there. Anything installed previous to 1997, they are likely to be not as efficient as a brand new boiler could be. The most efficient type of standard boiler you can get at the moment is a condensing boiler, which basically some of the flue gases, rather than coming straight out into the atmosphere, are condensed and taken back in and burnt again in effect, so you're getting a higher level of efficiency. You're getting kind of more bang for your buck for the fuel that's going through that boiler. So they're going to be up to 92-93% efficient for those types of boilers. With a condensing boiler, you do have to be quite careful with where it's placed. It has to be placed on an external wall, because there's a condensate pipe which needs to come out of the external wall as well. So you need to make sure that the location for your boiler is appropriate for that technology. Looking at switching the heating type, so rather than just replacing an old gas or oil boiler for a new gas or oil boiler, which will give you an improvement in the efficiency of your system, looking at possibly switching fuel to a lower cost, lower carbon emission system is something that we advise a lot of organisations on as well. There's a few different kind of options, and I think we're going to go to another round of questions now to see if anything's come in.
Yeah, sure. I think you've kind of really answered this question a little bit. Someone was asking how old does their boiler have to be before they should think about replacing that, but I think you really have addressed that.
Sure.
That question. And another one is that they've heard biomass boilers can be unreliable, and is that true? Again, maybe you're going to touch on that in a second, but you might want to answer that briefly.
Sure, yeah. I mean, any boiler, any piece of kit can be unreliable. It depends on generally the rule is you get what you pay for. There are different makes and models available, and there are top of the range ones and not so top of the range ones. Generally, if your boiler is installed by a suitably qualified professional, and for every different type of system there are accreditation lists that you can go to find your installer. And if you have an annual maintenance contract, so the boiler's looked after properly to make sure it kind of runs well, then there shouldn't really be a problem. Again, touching on the first question as well, if you've got a maintenance contract, then any kind of standard boiler should be able to run effectively for up to about 15 years, we would expect.
Great. Someone's asking, where can they find out more information about benchmarking?
About benchmarking, the CIBSE website is a good one to go to. That's the Chartered Institute for Building Service Engineers. Also, it's a lot of the CIBSE documentation you do have to register for, but there are a few kind of free bits and pieces on there as well. A good thing to do is just to speak to somebody like ourselves, independent consultants, who will have a good idea of where you sit and good experience with working within the different sectors as well. So I would say speaking to people like ourselves and just that general CIBSE website are probably the best two places to go.
Excellent. Thanks, Rob. Someone's also asking if the slides will be available at the following the webinar, and they will. We'll also share the recording and the slides, but we'll move on now. I think I'm just going to run another quick poll, and it's really building on just the swapping of heating type that Rob's going to move on to, and we want to just ask people, what heating type do you currently use? So on screen now you'll see that the options are electric, natural gas, oil, LPG, or some form of renewables, whether that be air source heat pumps, ground source heat pumps, or solid fuels such as biomass. So natural gas is the winner at the moment.
As we'd expect, yeah. It's the biggest heating fuel used across the UK. Where there's natural gas available, it's generally the cheapest option. Renewables change that equation a little bit with a UK government scheme called the Renewable Heat Incentive, which I'm sure some of our audience will have heard of, but I'll touch on a little bit later on. They changed the economics as it's a financial benefit from the government for using a clean heating source, which does bring them in line with natural gas. But generally, if natural gas is available, it's going to be the cheapest way to heat any building.
Great, and so I've just shared those results on screen with you now. 35% electric, 50% natural gas, 5% oil, no one LPG, and 10% renewables. Something of interest as well might be the biomass webinar that we had last week, where Seamus went into much more in-depth detail about biomass boilers. So if you are considering renewables and biomass is one of your options, you might want to check out that webinar. Okay, so I'll hand the slides back to Rob, and if you've got any more questions, then don't forget to pop them in the questions box, and we'll stop again at the end to ask a few more questions of Rob. Thanks.
Okay, well, yeah, as I mentioned there, if you're on a high price fuel such as oil or LPG, then replacing that with a renewable system it really makes excellent financial sense. Or obviously, if you're able to have a mains gas connection and you don't currently, then that's definitely something worth looking into. You can speak to Scotia Gas Networks, are the best people to speak to about getting that connection set up. getting yourself a natural gas connection can be an expensive business. It really depends on kind of where the pipes are running nearby to you, and just what's going to be involved in extending that pipework into your organisation, into your building. The other alternatives for fuel switching, as Lindsay mentioned, they are generally renewable options, biomass, which is burning wood in the shapes of pellets or chips or logs, or heat pumps, ground source or air source heat pumps, which heat pump technology is basically the same as a refrigerator, but in reverse. So where the fridge is extracting the heat from the box inside where all your food is, and like I said earlier, the fridge just kicks it out the back, what a heat pump does is extract the heat from the outside atmosphere. A ground source heat pump has coils underneath the ground, so it extracts the heat from the moisture in the ground. An air source heat pump extracts the heat directly from the air outside, and runs that through an expansion and compression process, which then delivers that heat into hot water, which can be run around your heating system through a standard radiator system. So they're definitely, I mean, we're moving out of the area of low cost alternatives here. When you're looking at renewable heating systems, they are generally a bit more expensive than a standard gas or oil boiler, but the running costs can be much lower, the environmental impact is much lower, and as I mentioned, with the renewable heat incentive, as we've got a bit of information on the slide here, they really can be a game-changing option. The renewable heat incentive is a UK government scheme, whereby, as I said, you get paid per unit of heat delivered into your building through a renewable heating system. It's quarterly payments. The rate that you get paid digresses over time, but it's fixed at the time that you commission your system. So if you were to install a renewable heating system and complete all the paperwork tomorrow, the rate that you're allocated tomorrow is what you're paid for the next 20 years, linked to the retail price index. Somebody who does the same installation 3 months down the line might be allocated a slightly lower rate depending on market performance at that stage, but once you're signed into the system, that's your rate fixed. And it's there purely as an incentive to help pay back the higher costs of that type of system. Generally, you're looking at about, with the RHI factored in, you're looking at about a 10-year payback time for most renewable heating systems in the kind of the small to medium size range. The next tip we're going to talk about is looking at your heating controls, having a good idea of when your system's coming on and off and what temperature your different spaces are running to is generally a good way to make sure you're only using as much heat as needs be. There are lots of different ways you can control your heating system. A simple timer like most people would have just in their home to set the heating to come on and off at set times in accordance with your working pattern or shift pattern, whatever happens to be the case in your own organizations. You can get slightly more sophisticated 7-day timers, so you can have different settings for different days of the week. Optimized controllers generally will have sensors outside to see what the temperature is like outside. You can get ones which can check humidity and things as well, so they can factor that in, and they kind of quite intelligently control your heating based on the external circumstances. They can learn what you like to do. They learn the way that you control the system and adapt accordingly. Zonal controls, if you have a large site all heated by one boiler, then it's possible to have different zones within that site set at different temperatures and different timing schedules as well. So again, you can make sure that you're only using as much fuel as you need to heat your space in quite a well-controlled way. System thermostats are slightly different to the next bullet point there, thermostatic radiator valves. Thermostatic radiator valves are a thermostat on a radiator, as it sounds. Again, most people have these in their home, and what they do is they stop the flow of hot water to that radiator when the area around that radiator is hot enough. They don't turn off the actual boiler. A system thermostat, which is a little thermostat you'll have on a wall somewhere, once the area around that thermostat reaches the temperature you set it to, it will turn the whole boiler off, so it will make sure that no more heat is being produced. You need to be very careful where you're placing system thermostats. If you've got them next to a door which is opened quite often, then obviously it's going to think that the space is colder than maybe the rest of the space is, so your heating is going to be on more than it needs to be. If it's in direct sunlight, then your system thermostat is probably going to think that your space is a lot warmer than it generally is, so you might find that the heating's not on as much as it needs to be. So when you're designing a system and thinking about where to place your thermostats, you need to be quite careful in the placement of them. And a building management system, again, these are more appropriate for quite large buildings with possibly quite complicated systems, maybe a few different sources, a few different areas being heated at different times. But they generally incorporate all of the previous points on that slide there into one kind of computerized system, which you can get very good management data and analysis from your actual heat use from, and you can manage the different areas of your building from one central computer point or a few different dispersed computer points throughout the building, whatever suits your operation the best. A few more points about thermostats there. I think I've covered them already. Really, just the need to be careful about where you're actually locating your thermostats and making sure that your temperatures are appropriate. Again, this is the type of information that you can get from benchmarking documentation, just what a comfortable temperature should be for the different types of workspace that you might have. So it's just something to be aware of when you're thinking about how best to control your heating system. The next point, reducing uncontrolled air leakage, basically draft proofing. We spoke a little bit about the insulation of the actual structural elements of your building, but you'd be amazed to see how much heat is lost purely through drafty windows, drafty doors, that kind of thing. It's quite easy to check ventilation levels. I mean, the simplest kind of old-fashioned test you can do is walk around with a candle and see when the flame blows, and if you know that the flame's blowing, then you've got a big draft there, and it's something which you need to look at. Draft proofing improvement measures, they're very simple, very low cost. You can get them from most major DIY stores, draft proofing strips for doors and windows, just making sure your windows are fitted properly in the first place. The little device you can see on the screen there is it's a thermal probe, so you can test different elements of your building, different areas of your building for what the temperature is. So if you think there's a draft somewhere and you can't detect it, then you can have a look at the space around that window or door with one of these pieces of kit you can pick up for less than £100 in most DIY stores, and you can get a good idea of where there are some possible areas of heat loss that you might be able to target. Some people might have seen kind of thermal imaging cameras and reports, and they basically do the same job as the thermal probe there, but a good thermal imaging camera will cost you getting up towards £1,000 rather than less than £100 for this. So while they're suitable for their more sophisticated purpose, just for a quick check of where you might be losing heat, there's a much simpler piece of kit that you can invest in. The distribution system is a big thing, especially if you're looking at switching your heating type, like we mentioned before, looking at a different fuel or a different type of system. The distribution system is basically your radiators or underfloor heating, if you have underfloor heating. If your system's clogged up, if you've got an old radiator system in your building, if it's not been kind of cleaned out within the last 10 years, it's likely that there's quite a bit of gunk in there and it's not working as efficiently as it can be. So a simple power flush or a chemical flush, which any kind of plumber, heating engineer would be able to do for you, can increase the efficiency of your heating system by 2, 3, up to 5% sometimes we've seen as well. So it's a nice, simple, low-cost thing to do, which can have a real impact. Replacing old radiators, generally newer radiators are a lot more efficient, so you'll be able to get the same heat output from them for a much smaller physical space of radiator. So if you're doing any kind of work to the building, if you've got the floors up for any reason, or you're doing any wiring or decoration, and you've got old radiators in there, then it might be worthwhile thinking about replacing them while you're doing that. Flow and return temperatures with condensing boilers, and again also with heat pumps. These type of technologies work at a lower flow temperature, So the water flowing through your radiators or underfloor heating system is not as hot as it would be with an older style gas or especially oil boiler. So that means that you don't have to burn as much fuel to heat that water to pump it around the system. The flip side of that is that you need a slightly larger, physically larger distribution system. So if you're delivering your heat at a lower temperature over a larger surface area, you get the same amount of actual heat delivered into the space. So it's an issue of consideration when you're designing a heating system, making sure that your distribution system is matched adequately to the actual fuel type and the boiler type that you're going to be using as well. And things as simple as making sure that your radiators aren't blocked up. You'd be surprised to see the number of times we go into an office and desks with boxes underneath them and old Christmas decorations or stuff right in front of a radiator, and there's no heat getting out of the radiator into the space. It's as simple as a quick walk around of your site and making sure that the pieces of kit which are there to deliver heat into your space are actually being allowed to do that job. So it's a nice kind of simple check which everyone can do. Staff engagement. It's all very well environmental managers or directors or whoever is the decision maker in the organisation being fully on board with the kind of the message which we're trying to get across here, and the fact that you need to be well aware of your energy use, and you need to be constantly trying to make that as low cost as possible. If the staff aren't on board with that message, or if you don't pass that message down effectively, then it's not going to get anywhere really. I'm sure a lot of people will recognise a few of the statements on there as to why should people bother, and staff engagement is something which we've done a lot of work with. I know Lindsay has worked quite heavily on some of the tools that we have as well, so she might like to chat a little bit about that.
Yeah, absolutely. I mean, we spoke to organisations. It's something that people find really challenging, and it's slightly intangible, and dealing with people can often be much more difficult than installation of new technology. And so we understand those pressures, and it really is about explaining to people why they need to be involved in something and making sure that it's really clear to them what it is that you're expecting them to do, what behaviours you want to see from them, and not expecting to tell them once and for those behaviours to change. It really is unfortunately a slower process, and you need to make sure you're constantly reiterating in a kind of positive way what it is that you expect from people. We've done some work on screen now actually developing a thing we call the staff engagement toolkit, and it really is recognising that organisations are struggling for time and resources to be able to get their staff on board. So we have got some materials there that perhaps you might want to take a look at after this webinar, which can help you engage your staff on the issue of heating. I mean, maybe you've got staff that are turning up thermostats and when you've asked them not to, and it really is, no one's doing that out of anything malicious. It really is just about explaining to them why it's important and getting them on board right from the start, and perhaps involving them in some of your initiatives. But we've got things from staff training right through to posters and stickers and lots of other advice and things that you can utilise from that staff engagement toolkit. And so after this session I can share that link as well, and of course you can contact the helpline if you want any more advice and support around engaging your staff, whether that be one of our implementation advisors coming on site to run a drop-in session or a workshop or whatever you think might fit best.
Thank you, Lindsay. And the last one is really a bit more of a specific one, but it's something which we're seeing in quite a bit of kind of recently in some of the work that we've been doing, and it's for kind of large industrial spaces, and I'm not sure if this is entirely relevant for a lot of the people here, but I mean, if not, you can glaze over at this bit, and if it does, you can kind of pay a bit more attention than you have been possibly. But I mean, generally there's quite a lot that we can do for kind of factory spaces and things like that. Making sure interlocking heating controls are, if you've got a few different areas which need to be heated in different ways, you can make sure that they communicate with each other appropriately, so the system isn't trying to heat one space and kind of cool another space, so the systems are fighting against each other. Fast opening roller shutter doors, if you've got big factory doors, having them open for as little time as possible is going to keep as much heat in the space as possible. Air curtains, slight heating a sheet of air in between any kind of warm spaces and spaces where there might be some heat loss can be an effective way to act as a buffer for heat within that warm space to exiting quickly. Again, flexible doors, making sure that you'll be able to imagine them kind of plasticky doors, so you've got less time that the actual door is being open, so there's less chance for heat to escape. Control heat gains, if you've got big kind of processing plant, like I mentioned in one of the earlier slides, if you've got a big plant which is kicking off a lot of heat, such as cooking plant, welding machinery, things like that, you can extract the heat, you can use that heat and kind of feed it into your system, so you don't have to burn any more gas or electricity to provide heat if you've already got some heat there. So heat recovery from plant and things which are in the building. Again, solar gains, similarly, you can factor that into your overall heating system design to make sure you're making the best use possible of the circumstances which are individual to your organization and to your operation. De-stratification fans is quite a popular one actually for large buildings. Obviously heat rises, so if you've got a high ceilinged factory and there's a lot of heat going up to the top of that building where there's nobody working up there, so you don't particularly need that heat. A de-stratification fan is a relatively simple low cost option, and it basically circulates the heat back around the actual used space within the building as well. And I've seen savings of up to kind of 10% purely from installing a few de-stratification fans in kind of factory spaces. So it's definitely something worth considering if you have that type of space that you're working with. Radiant heat is another one which is not specifically for larger organizations, but generally that's where it's come from. It's like a lot of technologies, it's becoming kind of miniaturized, so it's coming down to smaller and smaller applications. But radiant heat generally uses infrared radiation to heat surfaces rather than the space. So rather than convection heating, creating air currents and passing that and heating the whole of the space, a radiant heater will just heat the items and the people which are in that space as well. So it can be a lot more efficient way to provide heat to any organization really nowadays with the way the technology is going. And that's us really. That's a quick summary of the things that we looked at. I see there's a few more questions coming there. Are we at a question stage now? Not quite yet, no, sorry.
No, that's fine. We can have questions then I'll come back to talk about the free support. That seems like the most sensible way of doing it. Yeah, we've had quite a few questions. First one, someone's saying that what can we do to upgrade our heating system if they don't own the building?
Well, obviously whoever owns the building will be the person to make the decision. What you can do, you can speak to somebody like ourselves to help come up with a list of options and build a business case is the only thing you can do really. Even if you don't own the building, you're likely to be the one paying the bills. A lot of landlords will consider installing some new technology. If your heating bills are going to be coming down, then that might be something that they can kind of factor into their rent arrangements as well. Basically, you just have to make the business case basically, and anybody who owns a building, it's in their best interest to make sure that that building is as efficient and well maintained as possible. So as long as you can make the case, then that's generally the kind of the way to go.
So, kind of building on, you talked about energy management software and systems, but someone's asking how large does their organisation have to be? Now, I don't know if it's easy to answer this, but just maybe some guidance on that maybe.
That is quite a tricky question to give a straight answer to. I mean, generally, it's not so much the size of the organisation in terms of number of staff. It's the complexity of the building that you're working with really. If you've got a few different areas which need to be heated in different ways or are heated via different sources, then that's when it's worthwhile looking into kind of bespoke or even more kind of generic specific building management software. Generally, if you've got a heating bill over I would say about £15,000 per year, something like that, then it's definitely something which is worth looking into. And again, that's the kind of thing that we can help with Resource Efficient Scotland, is putting an estimate on how much that type of software is likely to save for your organisation against how much it's likely to cost to have it installed in the first place, so you can make the decision as to whether that's a worthwhile investment for you to spend your money on.
Excellent, thanks. Can modern controls be installed on an older heating system?
Absolutely, yeah. I mean, like I said, the older radiators are likely to be not very efficient, so you can put a building management system, or even modern kind of timer controls or modern thermostats within the system, and they'll give you some improvement on the performance of that system. They probably won't give you as much improvement as you would get from spending a little bit more money to upgrade the system itself. And generally, any time we recommend completely removing a system and putting a new one in, a full suite of kind of modern controls will be part of that kind of new system recommendation. So in answer to the question, yes, you can absolutely do that, and you will get an improvement to the efficiency of your system. But if you have an older system anyway, it's probably going to be a bit more worthwhile in spending a bit more money to improve the system as a whole, including those kind of modern controls as well.
You've touched on the renewable heat incentive, but someone's asking, is there funding available for installation?
That's a tricky one at the moment. There is a Scottish Government loan which is funded, well, it's administered by the Energy Saving Trust and delivered through ourselves, Resource Efficient Scotland, and that's available for any recommendation in one of our reports, or a recommendation in a Green Deal report, which is another type of energy survey any business can get done. And that's an interest-free loan of up to £100,000 for renewable technologies, where you'd get the renewable heat incentive or the feed-in tariff for electricity producing technologies such as solar panels or a wind turbine. It's a 5% interest rate on that loan. It's not interest-free anymore, and that's because of European regulations, which say you can't have two different sets of state funding for the one installation. So the interest-free part counts as the interest that you don't pay counts as state funding. So to pull themselves out of that complication, there's been a small 5% interest rate attached to the loan for those technologies. So that's there. Unfortunately, at the moment, this current financial year's allocation has all been spent, and we haven't had confirmation yet from the Scottish Government as to whether it's going to continue into the next financial year. We get to this stage every financial year and the story's the same. Usually around about the last week of March we'll find out as to what the scheme's going to look like in the next financial year, or if indeed there is going to be one. They're currently operating a waiting list, so they're still accepting applications, but like I say, there's no more funds to be allocated for the rest of this financial year, and we're waiting to see what the upfront help might be available for next financial year.
Great, so watch this space. The final question we've probably got time for is that someone says they were offered a biomass by a biomass supplier, a boiler, for free, to install the boiler for free. Is that possible, or should they be suspicious?
It's definitely something you should take with a little pinch of salt. And generally, these systems do exist, and they have developed from a very similar model, which was quite popular a few years ago with solar photovoltaic panels, whereby the installer will install the piece of kit and retain ownership of that piece of kit, but also retain the government payments which are allocated to that piece of kit. So for a biomass boiler, the installer would get all of the renewable heat incentive payments because they own the boiler. You would still have the use of the boiler and the cheaper and more, generally cheaper and more environmentally friendly fuel source, but you wouldn't get the major benefit for that type of technology, which is a renewable heat incentive. So it's not a scam, it's a clever thing which a lot of installers are looking at doing at the moment in order to maximise the RHI input coming into their own operations. Generally, if you can afford, or you can look at borrowing the cost of installing the piece of kit that yourself, then it's going to be a much more cost-effective option to do that and take the renewable heat incentive or the feed-in tariff. So if you can afford the piece of kit, it's going to be a better way to go than going through one of these kind of rental schemes, as they're called.
Fantastic. We'll finish up on the questions there. I'll just quickly mention, Rob's talked about it and I've mentioned it as well, but yeah, we do offer free advice and support, one-to-one support for every Scottish organisation, whether that be a quick telephone call about a specific question or somebody coming out on site to take a look at things in person. So it's really worthwhile. If you've got any questions or anything that you'd like some further support on, then definitely reach out to the helpline. The number's usually on screen there, but I think it's 0808 808 2268, but it's on the website, or drop us an email, and yeah, one of our implementation advisors will be able to help you with any projects or initiatives you want help with. And so that's really it for today. We just want to thank Rob for his time, lots of great ideas and a really kind of clear step-by-step process to follow. And yeah, thank you everyone for joining. We've got lots more free training workshops and webinars coming up, so keep a look on the website, and we hope that you can join us at those next webinars and events. So thank you so much, and I'll share the slides and the recordings with you in the next few days. Fantastic, thank you.